Okay, in this video, we're going to be covering the last section in Unit 2, which is 4.7, inverse trig functions. So basically what we're doing is we're finding the inverse of the trig functions. If you remember from college algebra, inverses is when we switch our x and our y. We switch them and then we solve for y. In this case, if we already have a graph, we're just switching the x and y values. So instead of it being like this, it's going to be like this. Okay? All right. When we do this, we can see that our domain is now from -1 to 1, and our range is all real numbers, except we don't want to use the entire all real numbers. What we're going to do in this case is we're restricting it because these values repeat. So we're going to use only strategically a portion of the function, the inverse function. So for the function of sine, we are going to restrict it from -pi/2 to +pi/2. So let's look at the unit circle for that. Okay. So in this particular case, remember we said that quadrant 1, all trig functions are positive. All right. Well, let's look at sine. Which two quadrants is sine negative? Okay. Hopefully you said quadrant 3 and quadrant 4. Well, we're only going to use 2 out of these 4 quadrants. One for positive and one for negative. We will never ever be using quadrant 3 for any of these trig functions because we always want to use quadrant 1. Remember, quadrant 1 is positive for all of them. So if we're not using 3 and quadrant 1 is positive for sine, which other quadrant is sine negative? Well, sine is negative then in only quadrant 4. So when we're looking at our sine functions, we're going to pick these two quadrants. This one to represent our negative values and this one to represent our positive. We are going to use a -pi/2 or +pi/2 to go into quadrant 1. Okay, so that's why we're using the restrictions of -pi/2 to +pi/2. All right, so let's go ahead and see what that actually means. So anytime you see an inverse, which is this -1 here, what we're going to do is we're going to say, okay, we are no longer looking for our ratio of sine. We are actually given the ratio. What we're actually looking for is theta. So anytime you see the inverse of sine, it's actually asking you for theta. So if I were to take sine and move it to the other side, it would look like this. Sine theta is equal to -1/2. What we're looking for is theta. Now, remember when you're dealing with your inverse functions, you have to restrict it to the two quadrants. Since our ratio here is negative for sine, we're going to have to find a value in quadrant 4. Look at our ratio, -1/2, and here it is. So we can see that in order to find this value, we are going to use -30 degrees, which is -pi/6. So your answer here, theta has to be -pi/6. Now, this is a crucial note. If you state that theta is 11pi/6, and even though that is correct, you're going to get it wrong because you have to use the restrictions between -pi/2 and +pi/2. So it will be wrong if you use 11pi/6. Remember, 11pi/6 is going into quadrants 1, 2, 3, and then 4. We want to go directly from 0 down into quadrant 4 without going through the other quadrants. Okay, let's do the next one. Number 2, arcsine. Arcsine is another way that we can represent inverse. So you will see it one or the other. Okay, again, this is going to be equal to a theta. This is our ratio. Anytime you see arc, it's our ratio. In other words, it's the same thing as saying sine theta is equal to that ratio. So what I'm going to do here is saying, okay, sine is positive. That means I have to be in quadrant 1. And I'm looking for a theta where sine is square root of 3 over 2. In this case, pi over 3. So theta will be pi over 3. Okay. Over here, we're going to do the same thing. Again, you have your inverse, your -1. That's going to be equal to a theta. So I can write it as sine of theta is equal to 5 pi over 4. Don't get confused and see this and think that that is theta. That is not theta because the -1 or the word arc in front of the trig function says that whatever is attached to that is actually a ratio. This is one that we do not have on the unit circle. So one of the easiest ways to do it is just to use your calculator. I'm going to go ahead and now I can use the second sine button. That will give me your inverse. Second sine, there's your -1 right there. And then I'm going to put this in parentheses. 5 pi divided by 4. Close the parentheses. When I press enter, you see that this is a domain error. Let's look at and see why it's a domain error. Okay. If I were to plug in the ratio 5 pi over 4, I will see that the value comes out to close to 4. So when I go to my graph, I can see my y values must be between -1 and +1. That means that the 4 is above the sine graph, which means that theta does not exist. Okay? There is no theta that's possible to give us this ratio. All right, next page. Let's look at cosine now, okay? Cosine has the same restrictions, okay? So if we're using our unit circle, remember we're not using quadrant 3. Quadrant 1 is for all positive trig functions. So if we're using positive in quadrant 1 for cosine, we're not going to use quadrant 4 because cosine is also positive, which means we're going to use quadrant 2 for all our negative cosine. Okay? From 0 to pi, there's the 0, there's our pi. All right, let's go ahead and look at tangent now. Tangent, if you can see here, is using this particular one. So we're also going to use -pi over 2 to +pi over 2. Okay, we're going to keep these two quadrants together, which is of course going to be quadrant 4 for negative tangent and quadrant 1 for positive tangent. Okay, so we have those values as well. Let's go ahead and do a few of these examples. Okay, for arc tangent 1. Okay, again, this is like saying inverse tangent of 1 is equal to theta. In other words, tangent of theta is equal to 1. Since our ratio is positive, we're going to use our unit circle and determine what theta gives me tangent to be positive 1. It's going to be pi over 4. So theta here is equal to pi over 4. Okay. For the next one over here, we're going to do the cosine of -1/2. Then again, because of the arc or the -1, we're looking for theta in this case. Okay, so on this problem, cosine, the ratio is negative. Cosine is going to be negative in quadrants 2 and quadrants 3. Because we never use quadrant 3, we're only going to use the values in quadrant 2. Okay? Going back here, we're saying x has to be negative 1/2. X is negative 1/2 at 2 pi over 3. So we're going to say theta is 2 pi over 3. Okay, the next one is cosine, arc cosine of 3 pi over 2. I'm going to go ahead and write it like this. Cosine, okay, cosine of theta is equal to the square root of 3 over 2. Since the ratio is positive, we're going to be using quadrant 1. And cosine is our x value, so I'm going to my x, and here it is. Here is x is equal to the square root of 3 over 2, which means theta has to be pi over 6. So here, theta is equal to pi over 6. Okay? The last one we have listed here is tangent of 0. Remember, anytime you see the negative 1 or the arc, that is looking for a theta. So tangent of theta is equal to 0. Where is tangent equal to 0? If you look at your unit circle, tangent is equal to 0 here. Remember, tangent is y over x, so this is 0 over 1. So theta is equal to 0. All of these we're using are radians. Okay, so this little chart here is not 100% complete. All of the trig functions are listed in quadrant 1 are positive. Sine and tangent are negative in quadrant 4. Notice over here you're only given cosine. Cosine and actually cotangent are going to be negative in quadrant 2. Okay? So I just completed your table. We never use quadrant 3. All right, let's go ahead and find the next values. Okay? Over here, it's saying use your calculator to approximate the functions. Now, if you notice these ratios here, remember this is equal to theta, this will be equal to theta, and this will be equal to theta. All of these ratios are ratios that are not on our unit circle. So we cannot use the unit circle to find the radians. What we're going to do, it says here use degrees or radians. And I'm just going to do arc cosine. So I'm going to do second cosine. And I'm going to use that ratio. 3 divided by 5. Close it and press enter. And theta here is going to be equal to 53.1 degrees. Okay? If I were to do radians here, I would leave it in exactly the same form, and I would just make sure to put it in radian mode. So if I press enter here, I could say theta could equal 0.93 radians. And I would just leave it as 2 decimal point places like that. Okay, the next one. The next one is the same thing. These are not on the unit circle, so all we're doing is plugging them into the calculator. Second sine, and then use the negative 0.457 and press enter. Negative 0.47 radians. If I wanted to do in degrees, I would make sure that my calculator is on degree mode, and then when I press enter, I get so negative 27.2 degrees. Going on to the next one, so we'll do degrees first. I'm going to put theta is equal to, and I'm going to do second tangent, negative 2.09, and press enter. That will get me a negative 64.4 degrees. Okay. For radians, we would go ahead and make sure to change it to radian mode. Let me get that question back. There you go. And then press enter. And here you would have negative 1.12 radians. Okay, let's go on to the next one. Here it says use the calculator to approximate, that means we're not using exact values, the degree measure, but we must be in degrees, to 1 decimal place the angle where theta is between 90 and 180 degrees. This means we want to be in quadrant 2. So we're going to use arc sine. I want to solve for theta, which means I have to separate the sine from theta by using the arc. I'm going to do theta equals arc sine, or inverse sine, of the ratio 3/8. Okay? Now remember, technically in this quadrant, we're going to get a answer in quadrant 1 because those are the original restrictions. So what I'm going to do here is I'm going to make sure I'm in degree mode. Let me go ahead and change that now because we want degrees. So I'm going to go ahead and change that to degree. And then I'm going to type in this information. So second sine, and then the ratio is 3/8. Notice that this is not in quadrant 2 like it's asking us for. This is in quadrant 1. So here, the angle that we find is theta is equal to 22 degrees. But since we want a degree in quadrant 2, we're going to have to determine what this particular angle is. We're going to go from here all the way to here. Remember, sine is positive in both of these quadrants, so the ratio could be positive over here as well. So how do I solve for this? Well, these two angles, if this angle is 22 degrees, this angle is 22 degrees as well. Okay? So how do I find the entire distance over here? Well, that's going to be theta is equal to 180 degrees minus 22 degrees. Okay? Use your calculator and you find out that to be 158 degrees. So theta has to be 158 degrees, and that will give me that specific ratio. Okay, this information here is very general. So anytime you have a sine and an arc of a sine, the value of your x will be the answer as long as it's between those specific points. Okay, same thing here. Here's your arc sine, here's your sine. It will be the value of x given it falls within those restrictions. So let's go ahead and look at this first example. Here you have arc sine and then you have sine. So it really, again, it doesn't matter which one comes first. As long as they're opposite each other, you want to make sure that the answer, as long as it falls within the restrictions, you're good. So here your answer will be the same thing as long as it's in with these restrictions. Negative pi over 6 is within the restrictions, so that's going to be your answer. Okay. For part B, you can see that you have, again, your sine values. Now, here, if you consider 7 pi over 6, we need to first determine which quadrant that's in. So I'm going to do 7 divided by 6, and I'm going to say, okay, 7 divided by 6, that is going to be in quadrant 3. This is 1 pi. This is 1.5 pi. And what we have here is a little over 1, but less than 1.5. So remember, we do not use quadrant 3. So we need to change our sine value from quadrant 3 to where sine is also negative in quadrant 4. Let me show you how we're going to do that. So here, I'm going to go ahead and draw the point that we're actually given. We're given this point right here. Okay, this is 7 pi over 6. We need to determine what our reference angle is right here. If you remember how to do that, you would be doing 7 pi over 6 minus 1 pi, because that's the part that's not shaded. Here we would get pi over 6. So our reference angle from the pink shaded area is pi over 6. Now if I want to translate that to quadrant 4, I would be going in a negative direction. So this theta here would be negative pi over 6. So here you would have negative pi over 6. Okay, so it's the same angle as the pink one, but it's in quadrant 4, and remember it has to be between these two restrictions. In this problem right here, it has similar things, but you can see that the angle for cosine is going to also be in quadrant 3. Now cosine in quadrant 3 is negative, which means we want to move our theta into quadrant 2 because we never use quadrant 3. We already have our reference angle, which is pi over 6. That's the pink area, but we want to move it to quadrant 2. This theta right here should be pi over 6. Okay, but we don't want this angle because that would lead us to believe it's in quadrant 1. We want the angle right there, this entire angle. How do I get that angle? Well, pi minus pi over 6 is going to be 5 pi over 6. That's going to be the answer for this theta. Okay. Okay, in this problem here, it's a little bit different. This looks like a ratio, but it's actually a theta because it's attached to your cosine. Okay, so here we're going to not look at this and think, oh, that's going to be a ratio. That's actually an angle. So if I'm looking at that angle is going to be negative. So I'm looking at this angle as theta as being 1/2. It's negative because it's going down. Now for cosine, that would be a positive ratio, which means I want to be actually in quadrant 1, because for cosine, remember, we're using these restrictions from 0 to pi, which means it has to be between quadrants 1 and quadrants 2. Since quadrant 2 is negative, we have to restrict our values to quadrant 1. So theta has to be equal to 1/2. Okay, it will have to be equal to 1/2. All right, let's go ahead and continue going. If you have questions on these, please just let me know. I know it can get a little bit complicated at times. Okay. Let's go ahead and do a few more. This is going to be done a little bit differently. I think these tend to be a little bit easier. We're mixing these two values together now. We have one trig functions with the arc of a different trig function, and here we have vice versa. So the first thing we're going to do is start in the inside parentheses. So I'm going to start with this one here. Now remember, anytime you see an arc or this -1, this whole thing is solving for theta. So I'm going to do this. I'm going to rewrite this ratio, and I'm going to say all of that is equal to theta. Now I'm going to switch the sign back over to the other side, so it'll look like this. Sine theta is equal to 40 over 41. Sine is positive in which quadrant? Well, hopefully you said we have to use quadrant 1 because all trig functions are positive in quadrant 1. So let's go ahead and draw that triangle. I'm going to draw it over here in quadrant 1, just like that. And sine is opposite over hypotenuse. So here's my theta. Opposite is 40, hypotenuse is 41. Can I solve for the x value? Hopefully you said yes. We're going to do 41 squared is equal to 40 squared plus x squared. Okay, so minus 40 squared minus 40 squared. We get x squared is equal to, use the calculator. Let me adjust this real quick. Okay, so we're going to do 41 squared minus 40 squared, and we get 81. So this is 81, which means x is going to be plus or minus 9. Because we're in quadrant 1, x has to be a positive 9. Okay, we're choosing positive. Now, when we come back here, what we can do is bring down our cosine, and instead of using this information, remember this information is the same thing as theta. I'm going to use theta. I'm going to go back to my triangle and say, what is cosine of theta? Cosine of theta is adjacent, which is 9, over hypotenuse, which is 41. Okay, and that's your answer. Okay. Moving on to part B, you can see that here we have another arc sine. So I'm going to write it out like sine of negative 40 over 41 is equal to theta. Remember, anytime it's arc or negative 1, it's equal to theta. Now I'm going to say sine is a ratio that is negative. So sine of theta is a negative ratio, which means that we're going to have to choose which quadrant to be in. We're going to be in quadrant 4 because we don't use quadrant 3 when we're dealing with arcs. So I'm going to go ahead and draw my triangle in quadrant 4. Okay, here's my theta, opposite, negative 40, 41. The math will be the same as we have over here. So x is going to be positive or negative 9. But since we're in quadrant 4, x is going to be positive 9. Okay. Again, we're going to bring down this and we're going to say cosine. And instead of writing this, we're going to write what it's equal to, which is theta, is equal to adjacent, which is 9, over 41. Okay. So that's your answer for part B. Okay, let's do another one. This one is going to be a little bit more generic because now we're not giving an exact ratio. We're giving a ratio combined with a variable. But the math is still going to be the same. So let's go ahead and do this one. Again, here is going to be what theta is equal to. So I'm going to rewrite it and I'm going to say arc sine 2x is equal to theta, which means sine of theta is equal to 2 of x. Here it's saying that the absolute value of x is greater than 2. So what we're going to be using here is we're going to say that this is in quadrant 1 because the ratio of sine is positive. So I'm going to go ahead and draw that triangle out in quadrant 1. Okay. Sine is opposite 2 over hypotenuse x. Can I solve for this length here? Yes, I am going to call this, I'm going to call this, let's call it A. So it won't be x because x is here. And we're going to go ahead and solve for this value here. I'm going to say x squared equals 2 squared plus a squared. Okay, we're solving for a, so x squared minus 4 is equal to a squared. If I take the square root of a, it will be a plus or minus x squared minus 4. Don't try to take the square root of these individually. It can't happen. But I can say a is going to be positive, so a is going to be equal to x squared minus 4. And there's my theta. Okay, let's go ahead and do the next part. The next part, we're going to bring tangent down, and instead of writing everything inside the parentheses again, we're just going to say that that's equal to theta. Okay, theta is here. Now, what is tangent of theta? Tangent of theta is opposite, which is 2, over adjacent, which is the square root of x squared minus 4. Okay, moving on to the next problem. Now we're doing word problems. Let's just go ahead and read this. It says the Eiffel Tower is 1,063 feet tall. A measurement is taken for the length of a shadow of the tower and is found to be 310. Well, here's our picture. Let's go ahead and start writing out our numbers. The The height of the tower is going to be 1063. A shadow has been determined to be 310 feet. So let me put my units there. Okay. Approximate the angle of elevation, so this is my theta, of the sun to the nearest tenth of a degree. So if I'm given this information, which trig function should we use? Well, hopefully you said use tangent. Tangent theta is opposite over adjacent. So I'm going to write tangent theta is equal to 1063 over 310. The feet will cancel out, so it's just your ratio. But since we're looking for theta, we have to separate the tangent from the theta. That's when we use arctangent. Okay? Make sure that your calculator is set to degree mode since we're looking for the degree. Okay? My calculator's on degree. I'm going to put second tangent 1063 divided by 310. Theta is approximately 73.7 degrees. Okay, in this next section here, we're going to be talking about secant and cosecant. Remember, secant is the reciprocal of cosine, okay? And we're using, in this case, quadrant 1, and we're using quadrant 2, okay? So reciprocal of cosine. If I go back to that little chart over here, here is cosine. Cosine, you're using quadrants 1 and quadrants 2. So secant, we're going to be using quadrant 1, and we're going to be using quadrant 2. For cosecant, which is the reciprocal of sine, you will see that we're using this quadrant and this quadrant for sine and its reciprocals. So what we're going to do here is also include the reciprocals. This will be arc secant, and here would be arc cosecant. Okay, for negative values. All right, let's go back to that page. Now let's go ahead and look at the information we have over here. Okay, and cotangent, we already talked about that one. Okay, so on this one here, we're going to go ahead and set this equal to theta. Okay, now if I were to write this out again, it would be secant of theta is equal to 2, right? So what is the reciprocal of secant? Hopefully you said 1 over cosine. So secant and 1 over cosine are exactly the same thing, and that is equal to 2, okay? How do I solve for this? Well, you can use the butterfly method. So 2 cosine theta is equal to, multiply those two together, 1. Now I'm going to solve for cosine. So I'm going to divide by 2 on both sides. So now I have cosine of theta is equal to 1/2. Well, which quadrant do we need to be in? Well, hopefully you said quadrant 1 because the ratio is positive. So I'm looking for a cosine that is positive 1/2, which is right here. So theta has to be pi over 3. So theta is pi over 3. Okay, let's do another one. For this one over here, we have cotangent. Remember, it's an arc tangent, so that means this value is equal to theta. If I bring it over, it'll be cotangent is equal to negative square root of 3. Now, I'm going to go ahead and change this back into a tangent. Remember, this is 1 over tangent theta, which is equal to negative square root of 3. You can do it this way, or you can say, oh, I know what cotangent is. Cotangent is x over y, okay? If you think of it like this and you look at your unit circle, you're going to look for a negative cotangent. Well, hopefully you remember cotangent is negative in this quadrant. So we're going to say x is equal to negative square root of 3 over 1. Okay, so negative square root of 3 over 1. So 5 pi over 6. So theta is equal to 5 pi over 6. Another way you can look at this is if I continue here and I divide it by 1, you can use the cross multiplication. I'm going to go ahead and do it this way and solve it another way. So I'm going to do cross multiplication. I get negative square root of 3. Tangent theta is equal to 1. Then I can divide by negative square root of 3. That means tangent of theta is 1 over negative square root of 3. Tangent, that means this is y and this is x. Okay, so when you go to your unit circle, you're going to be looking at quadrant 2 because tangent is negative, and you're going to say y has to be 1. There's a positive 1. X is negative square root of 3. It's right here. Now, one of the things, if you do it this way, that you have to be very, very careful is remember when we're dealing with tangent and cotangent, they are negative in different quadrants. You always have to refer back to the original equation. In here, we're looking for a cotangent that's negative, so we're using quadrant 2. If we were looking at tangent of being a negative value, we would typically look under quadrant 4. So be careful and always consider the original trig function. Okay. All right, we're going to go to this next one here, and we have cosecant. So let's go ahead and write it out. This is, of course, equal to theta. I'm going to go ahead and switch it over, and it'll be cosecant of theta is equal to a negative 2 square root of 3 over 3. Now I'm going to say, what is cosecant the reciprocal of? Well, hopefully you said sine, so I'm going to put sine of theta is equal to negative 2 square root of 3 over 3. Use the butterfly method in this case. I'm going to go ahead and do negative 2 square root of 3 sine of theta is equal to 1 times 3, which is 3. I'm going to divide by negative 2 square root of 3 on both sides, and I'm going to be left with sine of theta is equal to 3 divided by 2 square root of 3. Okay, rationalize your denominator. I know this is a lot of work, but we're almost done. This is going to be negative 3 square root of 3 divided by 2 times 3 is 6. Okay, and then simplify. Negative square root of 3 over 2. Okay, so which quadrant should we be in? Sine is going to be negative, which means we should be in quadrant 4 over here, and we're going to look at sine, and we're looking for negative square root of 3 over 2, which means our value is going to be this one. But remember, you can't just say theta is equal to 5 pi over 3. This is actually going to be negative 60 degrees or negative pi over 3. So your answer for here is theta has to be negative pi over 3. That's going to be your answer for this question. So this next question says, use a calculator to approximate arc cosecant of 8/5 in radians. So make sure you're on radian mode. I'm going to go ahead and change my calculator now to radians. Okay, so there I go. It's in radians. And now what we're going to do is we're going to go ahead and do the same thing that we were doing previously. I'm going to say arc cosecant of 8/5 is equal to theta. Now I'm going to go ahead and put my theta with my cosecant. So I'm going to say cosecant of theta is equal to 8/5. Okay? Cosecant is the reciprocal of sine, so I can say 1 over sine theta is equal to 8/5. Again, use the butterfly method or whatever method you want to do and cross multiply. So it's going to be 8 sine theta is equal to 5. Now I can go ahead and divide by 8, and I'm going to get sine of theta is 5/8. We're looking for theta, so that means I have to take sine over to the other side. So theta is going to be equal to arc sine of 5/8. Essentially all we did from the original one was just flip it. Okay, now what we're going to do is we are going to plug that into the calculator. Also realizing which quadrant we are in. In this particular case, this ratio is positive, so our arc sine will also be in quadrant 1. Okay, so I'm going to do second sine 5 divided by 8, close it, enter, and here I get theta to be approximately 0.6751 radians. It said to go to 4 decimal places, so I went to 4 decimal places. No degree sign. This is in radians. Okay, this concludes 4.7. It concludes Unit 2. Let me know if you have any questions. Please make sure to look at those worksheets.